Let us go through this problem. A ball is thrown vertically upward with a velocity 20 meter per second top, from the top of a multi-storied building. Then the height of the point where from the ball is thrown is 25 meters. Now, how far, that is, how high will the ball rise? That is the first question. Second question, how long will it be before the ball hits the ground? So it is something concerned with the time, because how long means time, right? So time is asked. Now you may get a confusion that, sir, you have got already the height 25 meter, then why should they ask this height once again? Can you explain? Very good. So that is the height of the building actually. So let me consider this is the ground, and draw a multi-storied building like this. You can represent like this. This is a multi-story building. So from the top of the building, he is throwing the ball. So this is A, this is B. And here, in fact, the height of the building, it means what? With the 20 meter per second, from the top of the building. H, that ball thrown from ground is 25 meter. So you have to be very careful. It means the height of the building is 25 meter. Do you understand this? Okay, right. Just a minute. Got it? Okay, right. So it means the height of the building is 25 meter, because this guy, he has thrown the ball from the top of the building, and it is clearly stated that the place where the ball is thrown is 25 meter from the ground. It means, which is nothing but the height of the building. Okay, so indirectly they have given, right? Okay, then let us proceed. And what about the total height? That is the question asked here. Please draw this. Okay, so let me say this is before it falls on the ground. That is the point at which the ball hits the ground. Let us consider this as x. Okay, when you consider this total height as x, and this height, okay, is x minus x naught, you can say. Okay, now listen to me carefully. What is the initial velocity given here? U is equal to 20 meter per second. And what is the acceleration should be taken? We have to consider the acceleration. What is that? 10 meter per second square, right? Then consider vertically upward motion of the ball. Okay, so let us consider case 1, upward motion of the ball. of the ball. Okay. So up to the highest point, right? Up to the highest point. Now it is u is equal to 20 meter per second. When the ball reaches to the highest point, it means the final velocity will be zero. Is it not? The final velocity is zero and it moves upwards. It means that is it is against the gravitation pull. So it is taken as minus 10. Take down. So when it moves upward, you have to consider this as minus 10 meter per second square. And then the upward time traveled is T1. Let us say T1 is the time traveling upward. So let me consider here T as T1, right? T as T1. Then what is the total height, the net height from the ground is X. Okay, take down the total height. Now let us apply the theorem. V squared is equal to what? Tell me. U squared plus 2AS. Either you can say V squared minus U squared is equal to 2AS or V squared is equal to U squared plus 2AS. Right? Okay. So V squared is equal to U squared plus 2AS. And next, and here, this S is nothing but X here, right? Therefore, V squared is equal to U squared plus 2AS. Ah, no, it is the total height. You just look at the diagram, okay? Look at the diagram. I have given this as a total height, right? Got it? And for which the acceleration is taken as what? Yeah. Now V squared is equal to U squared plus 2AX. We have to find out this X first of all, right? Because you have got the initial velocity, you have got the A, then you can find out X, is it not? And you have got the final velocity. What is the final velocity? Zero. So replace this zero. What is U here? How much? No, U 20 meter. So 20 squared here. Okay. So that is 400. Okay. Then 2 into what is A? Minus 10. Okay. And into X. Now find out the X. 20 meter. X is equal to, that is, this is 400. When it goes here, minus of 400. And what about this one? That is 20. So divided by minus 20. Okay, so it means 20 meter. So X is 20 meter. Okay, you got it? So X. So that is the first question. How high will the ball rise? It means what? You have to tell from the ground only. Are you able to follow? So that is 20 meter. Okay, right. So this is the first answer. Take down. But you had to present the answer carefully at the end. And then, uh, we- let us visualize like this. I got the ball here. See, this is the height of the building. Okay. The ball is kept here. The boy is throwing from A to B, right? Okay. So it is already given the height of the building as 25 meter. Got it? Now, what is asked? How high will the ball rise? It means that is from the ground, not from the top, right? But they are simply asked, when they are simply asked, that is, what is the height of the anything, height of the ball, means you must consider only from the ground. But if you are very particular about this, then you have to take this because the height, just a minute, and 1 minute, what is this? 20 meter, just a minute. No, wait a minute. So it is not 20, that height is 20. I think this must be 20 because it is traveling from here to here. Okay. So let me say, so this is x. Let us call this as x naught. Okay. So this x naught that is from that position is 20 meter. Now we have to declare this as 25 plus 20. That is 45 meter. That's correct. Okay. So you can put x naught. Right? Got it? So it is 20 plus 25. The total is, that is x is equal to, in this case, the total height, that is 20 meter plus already 25 meter. It means 45 meter. Got it? Right. Next. Now, it is taken as the time also. Okay. So what is the final time? The upward motion from A to B, let us consider from upward motion for which the time taken is T1, okay, for the upward motion, right? And the ball freely falls here. After reaching B, it freely falls here, okay? So at that time, what is the time taken? Let us call it T2. Now we have to find out T1 and the T2, okay? So the total time of flight should be calculated as T1 plus T2. Now the time, second question, time of flight. Now listen to me carefully. We know that is for the upward motion A to B and downward motion what? B to C. What is the upward motion? Upward motion is A to B. You understand? We follow A to B here, right? And the downward motion is B to C. B to C. Okay, right. Now, velocity at B, you know. So when it reaches the maximum height, what is the velocity of the ball at the maximum point? That will be zero. So V at B is zero. Take down this point. Therefore, we can apply this equation. What is our gravitation equation? V is equal to what? U minus gt because it's an upward one. Upward. So in that case, V is equal to 0. And what is U? 20 meter per second. And then what is G? 10 meter per second square. And then T1. Because this T1 is nothing but the time traveled by this ball from A to B, right? So T1. Now tell me what is T1? 2 seconds. Okay. Please make a note of it. Then let us proceed. From the top, the ball again falls freely under acceleration. Okay. Freely under acceleration. And the time taken here as T2. Okay. Then. And what is our regular equation? S is equal to for downward motion. Okay. S is equal to what is the formula? Ut plus half at square. So ut plus half at square. But you have to convert for this gravitation movement. So under the influence of gravity. Therefore, x instead of x you can put x. Is it not right? X and then this is the total distance traveling. How I have taken x naught or x. This is x naught. This is x. So the total distance. Okay, let us call it x and ut plus half what is a g into t. T is equal to t2 t squared because for the downward we have taken t as t2 a as g. Now you can substitute. And what is this? You know the value of x, you know the value of u, okay, and find out the value. What is the u here? When it starts, what is the value? 0. So u is equal to 0. Why? Because it, it starts coming down, falling. Okay. So in that case, find out g, you already know 10 meter per second squared. Find out T2. What is T2? T2 squared is 9. Therefore, T is equal to 3 seconds. Okay. Now, what is the total time traveling? T is equal to T1 plus T2. So, this is 2 seconds, 3 seconds, so 5 seconds. So, what is the first question answer? 45 meter. Okay, so how they are asked, you please read the question, whether it is from the ground they are mentioned or from the building. From the building. How they asked the height at the point where from the ball, okay. How long will the ball rise? Okay, how long will the ball rise? Better, it means that is a rise from the building only. So if it is rising from the building means 25 because they are not straight away asked as total height. Okay, so you can because it is a rising means from where it is rising. You have got already certain height. So let us be very clear about this. So ball you can put like this ball rising from the building to be on the safe side. Okay, ball rising from the top of the building is equal to how much? 25 meter per second. 20 meter or 25 meters? 20 meter. Oh, 20 meter. Okay. So that is 20 meter per second. That is the first answer. Second answer, the total time of flight. Total time of flight of the ball is equal to 5 seconds. Okay. Now, what are the key points here? You have to be very clear with the diagram, and you must note that the height of the building is 25 meter. Then you have to be very careful about the x. and then the time traveled for the entire flight. Okay, right? We will discuss another problem based on stopping distance of a vehicle. Better. Problem based on stopping distance of for a vehicle. Because when a brake is applied for a car, you cannot expect the car to be stopped instantly on the same spot. Okay, it will move for a while, right? Now, when brakes are applied to a moving vehicle, you can make a note of it. What is stopping distance for a vehicle? When brakes are applied, when brakes are applied to a moving vehicle, to a moving vehicle, the distance, the distance before coming to halt, that is stop, is called stopping distance. Do you understand this? Okay. In fact, this is a very important factor for road safety. And this value depends upon the speed of the vehicle and the efficiency of the brake system. Please note down what are the factors influencing here. The speed of the vehicle, speed of the vehicle, and efficiency of the brake system. Efficiency of brake system. So these are the key points. Now let us calculate the distance traveled by a vehicle that before stops. Let us call it a ds. Okay, so this can be called ds, stopping distance. Okay, so what is ds? Stopping distance. And what is stopping distance? The distance moved by the vehicle before halt. Okay, when the brake is applied. So ds, and now we know the formula v square is equal to u square plus 2a. Let me assume that it is moving in the x direction. So let me replace this x by x. S by x. Now the final velocity, after applying the brake, it is zero, right? Why? Because it is a halt. It is stopped by the brake. So final velocity is zero. Okay. And there should be some initial velocity. And also, what is the acceleration? Now let me replace this x by ds. Okay. So v squared is equal to u squared plus 2a ds. So v squared is equal to 0 and u squared plus 2a d at s. Therefore, what is ds? That is the stopping distance minus u squared divided by 2a. Okay. So this is a very important one. And this stopping distance is proportional to dash. What is that? The stopping distance is proportional to, directly proportional to dash. From zero to the initial velocity. square of the initial velocity. Okay. And the stopping potential, stopping distance is inversely proportional to dash. Okay. So now let us calculate like this. Take down, let us consider a problem. A car moving with a speed of 50 kilometer per hour can be stopped by brake, can be stopped by a brake after covering 6 meter. After covering 6 meter. It means what? That is the hmm, DS means that is the no, that's yes represents the stopping. So stopping distance, that's all. Okay. So DS, the stopping distance is given here as what? 6 meter. Okay. Just a minute. It's not the stopping distance. Here it is given brakes after covering 6 meter. Take down. After covering, stopped after covering 6 meter. What will be the minimum stopping distance? What will be the minimum stopping distance if the car is moving at a speed of 100 kilometer per hour? So it means there are two stopping distances, right? So this is one velocity, we can call it u1, okay? And this is one for this u1. This is the DS1, let me put. Okay, the stopping distance for this 50 kilometer speed. Now, what is the question asked? What is the minimum stopping distance, that is DS2, for 100 kilometer per hour? That is the second speed U2. Can you do this sum? It's very simple. It is only a ratio of sum, that's all. You know the stopping distance formula, what is that? Just apply that one. DS is equal to what? Minus U squared divided by 2A, right? Now let me study this as case 1. So ds1 is equal to minus u1 squared divided by 2a1, right? And ds2, case 2, minus u2 squared divided by 2a2. Okay. Now we have to find out first of all acceleration. And based on that, you have to proceed. Are you able to follow? Without acceleration, you cannot do. So how to find out the acceleration? You have got the equation v squared minus u squared is equal to 2ax, right? So what could be the final velocity? You know very well it is a 0. So minus u means here 50 squared up, okay? 50 kilometer. And let us do one thing, that is we had to give it in terms of meter per second. So you have to convert this into meter per second. How you can convert into meter per second? Let us put U1, that is 50 kilometer per hour. Okay. So 50 kilometer per hour means what? 50 into 10 cube meter divided by per hour. We want to convert this into, what is that? Meter per second. Okay. So meter per second means hour 3600, right? So that is equal to 50 into 10 cube divided by 36 into how much? That is 10 square. Okay. Otherwise, you can introduce that fraction, the conversion factor. What is that? 5 by 18. Do you know that? Okay, let me explain. So, in order to convert this a kilometer per hour, what you can do, that is 10 cube divided by it is a 3000, that is 36 into 100 seconds, 20. So it means 10 power 10 goes there, so 10 divided by 36, it means 5 by 18. So the factor is 5 by 18. So you can multiply that 5 by 18 also. Do you understand? Okay. Otherwise, you have to go like this. Right. So now the result is 50 into 5 by 18 means 120, 5 5s are 25. 250 divided by 18. How much? 125 divided by 9. That is equal to, can use the calculator and tell me. 125 by 9. Or you can keep it as such. Okay. Let us not worry about the, decimal. Let us keep it as, because we can easily strike this. So 125 divided by 9, 9 meter per second. So similarly, can you find out for U2? Find out quickly. What is U2? U2, second velocity. Second velocity is 100, is it not? 100. 100 and then 5 by 18, right? So 500 by 80, that is 250 by 9. Right. So U2 is 250 by 9. Okay. V2 is, U1 is this much. Okay. Now you can substitute here and get the, value of A. Okay. So now what is the formula? V squared minus U squared is equal to 2A. What is that? X. So you can substitute V is equal to final velocity, that is stopped velocity, means 0 after applying the brake. And what is the U1 here? First you will take the U1, that is V1 squared minus U1 squared and 2AX. Tell me, 0 minus, what is the first one? 125. So 125 divided by 9, the whole square, right? Okay, that is equal to, and 2 into A into that X, that is the DSA. Okay, for the first one. So what is that? 6 meter. Okay, now obtain the A value. Hmm. Pardon? Hmm. But you need the value of, what is the acceleration? You should know the acceleration, no? Yeah, for this you can find out the A. What is that A? What it? You want to use this formula, but I will discuss later. Let us complete this one. What is A? Do it first. Will it be positive or negative? Negative. Why? Because retardation. Okay? Right. So what is the answer? 125 into 125. Multiply it. You should not take that is a minus inside. Remember, this is minus of 125 the whole square. You should not mistake that, sir. Minus 125. No. Do you understand this? What I mean? For example, this part 125 should be taken as 0 minus, forget about minus, and 125. So best way for multiplying 125, 125 into 125. You can take 5 5s are 25, and you take this digit, add 1, so 13 into 12. So likewise you can multiply easily. 36 balance 3, 12, 15. So it means a 1525. So 156. So how much? Minus 16. Okay, right. So the A value is minus 16.07 meter per second squared. Okay, right. So approximately we can take it as a 16 also. Now roughly we'll take 16. So minus 16 meter per second squared. Okay. Then let us proceed with the second case. What is the second case? V is equal to case 2. V is equal to how much? 0. Okay. And what is the acceleration we got? A is equal to minus 16 meter per second squared. And we have to find out the x. That is the ds2. So you can apply the same equation. What is the answer? That is ds2 is equal to minus u2 squared divided by 2a2. In this case, you are taking the same a. A2 means A1 is equal to A2, that is called A. Now, I found out, I'll tell you the shortcut. Before that, you try to finish. Now, they are maintaining at same acceleration. It is a constant acceleration. They are not increase the speed. No, no, no. For decelerating, the braking system will be constant. The system is constant. Whether you go at top speed or a low speed, the braking system for which the acceleration is constant. What is that? What is the value? X. I mean ds2 minus then u2. What is u2 here? 100. You have to convert 250. Is it not? 250 by 9. So 250 by 9 the whole square into 1 by 2 into a. What is a? Minus 60. Okay. minus 60. Now tell me, answer. That is 250 into 250. How much? This minus of minus plus. And 250 means 625 divided by 18, right? Into 1 by 2 into 16. Finished? What is the answer? 2, 4. It's not 2, 1. Please check. This is not 18, 81, right? Because 9 squared is 81. So what's the answer? Done? 24.11. So 24.1. And what is this distance? The ds2. That is meter. Now you can, instead of roaming like this, okay, I initially I took this one. Okay. Now let us adopt second method. That is method 2. So here I have already written ds1. So ds1 is equal to minus u1 squared divided by 2a, because a1 is equal to a2. Do you know why? The same brake system is applied. Okay, right? And this is the important factor that determines the what? It indicates the braking efficiency. Is it not? This indicates the braking efficiency. So because of this braking efficiency, now what happens here? That is ds1 will become, I mean ds2. This is a. So let us consider ds2. So minus u2 squared divided by 2a once again, right? So we are interested in this ds2. Let us consider this as equation 1 and equation 2. Therefore, ds2 by ds1 is equal to, the a can be cancelled, 2a can be cancelled, right? And what is this? Minus of minus becomes plus. So u2 divided by u1, the whole square. So you can make use of this formula, right? Got it? Prashad, this is the one you wanted to initiate, right? But we must apply the logic here. That is, the current has gone here. Anyway, so ds2 is equal to ds1 into u2 by u1, the whole square. Okay. So in that case, what is ds1? ds2 ds2 is equal to ds1. What is the value of ds1? 6. 6. Okay, 6, and that is actually meter. But the speed is given in kilometer. I'll do one thing. We can convert this into kilometer easily. Is it not? Okay. So shall I put 6 into 10 power minus 3 meters, right? It is said 6 meter. Let me convert this as what? 6 into 10 power minus 3. Okay. Into, and then u2. What is u2 here? You need not worry about conversion of kilometer into meter. Why? Because these two velocities can be unit wise cancelled, right? So this is the strategy we are adopting. So what is u2 here? 100 divided by 50. So very comfortably we can do this, right? So it means 6 into 10 power minus 3. Is it not into? And what about this 100? 100, that is 2, that is 4. It means 24 into 10 power minus 3. So we can quickly arrive at in this method, right? Okay, got it? Are you able to understand? Huh? This is very easy. In fact, for multiple choice questions, you can adopt like this. So this is a big roundabout method. This is given as per your book, but I am interested to do it very fast so that you can calculate in this method. But you will get a rough answer 24. Okay, got it? Right? Okay, so I will give you some exercise. Try to solve this.